Hello friends, welcome to this video. In this video, I will be talking about infinite sets. After a long time, I am making this video, so extremely sorry, but I will try to complete the portion as soon as possible. Infinite set definition is really simple. A set which is not finite is called infinite set, right? It is so simple. It's really simple, correct? A set which is not finite is called as an infinite set. In the previous videos, we have discussed what is a finite set. A set is said to be finite if there exists a bijection between n to s, correct? If s is finite, then there exists such a bijection, right? Such a bijection function. Simple. Okay, so I know the definition of an infinite set. Infinite sets are mainly of the two types. One is called as, first type is countable infinite set, and the other is called uncountable set. Okay, so these are the types of infinite sets. Okay. So in this video, but I will be talking about just an infinite set. I will give you one of the example of the infinite set. Okay, the one of the example of an infinite set is natural number, set of all natural numbers. We will show that my set of all natural numbers is an infinite set. You might think it is so trivial, right? I know that I cannot count them, right? I cannot have a finite number of element inside set of natural numbers, right? That will never end. If you give me 1000, there is 1001. If you give me 1 million, there is 1,000,001. The number will never end. Hence, it is infinite. No, we will prove it in a genuine way by the definition that we have. Okay, so let us just prove it. In max, nothing can be trivial. If it is trivial, still you should be able to write it in terms of the definition and prove it or disprove it. Okay, so I'll just prove that my n is infinite. Suppose, by chance, suppose my n is a finite set. I am going by a contradiction, right? I am assuming the counterpart. Suppose n is finite, then my cardinality of the set of all natural numbers will be some number n, right? Okay, so if I say there are n elements, that means what? That means implies me there exists a bijection. There exists a bijection f from set of all first n natural numbers to set of all natural numbers. Correct? We have learned the definition, right? A set has a cardinality n, or there are n elements if and only if there exists a bijection between set of all first and natural number n. Now this n can be any big number, so large that it is there inside n still. Okay, so if there exists a bijection, means what? This map f is both 1 1 as well as onto. Okay, but for now I know my n has how many elements? N, right? So it is 1 2 till n are the elements of this. So what I will see is my f of 1 will go somewhere inside n. So let it go inside x1. Let it get mapped to x1. My f of 2, let it get mapped to x2. Similarly, my f of n will get mapped to xn. Since my map is 1 1, it is not the many to one map, right? So this all elements are what? This all element are distinct. If they are not, still I am totally fine with it. But I know these elements are distinct. I know my f1 goes to x1, my f2 goes to x2, and so on. My fn goes to xn. So what I will consider for, okay, these are for some xi being an element of n. Okay, what I consider is, I consider my s equal to x1 plus x2 plus dot 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 plus xn. Now I want to thought about this. I want to think about this. My this s is an element of natural numbers, means my s is over here, correct? Since my f is bijective, it is onto also, means for this s inside this natural number there should be some pre-image. Will it be there? Answer is no, but I'll just write it in a proper format. But there does not exist any y inside n such that my f of y will be equal to s. Why does that does not exist? Because I know my s is not equal to xi for any I. Because I know only elements, oh okay, not I, this is nothing but I running from 1 to n, because I know only this element has a pre-image, correct? Rest of the element won't have any pre-image, hence S is one of the rest of the elements. Hence I can conclude that my S does not has a pre-image inside this. Hence my assumption that there exists a bijection map must be wrong. If this is wrong, that means my first assumption that my n is a finite set must be wrong. Hence I can conclude that my set of all natural number is an infinite set. I hope you guys have understood it. If you have any doubt, any difficulty, just write it in the comment box. I will try to solve it within a day. Okay. Let's just go to the next page. Here there is a simple result which I want to just give it to you guys. The result is really interesting. The result state as, if a set S is such that there is a bijection B from natural numbers to S, then S is an infinite set. We know that if there is a bijection between two sets, then they have the same cardinality. Means if they have given S is such a set such that there is a bijection between n to S, this implies me my cardinality of n is same as my cardinality of S. That means my cardinality of S is nothing but elif naught. Elif naught is what? Elif naught is the number of element inside this. This is a notation for number of element inside this. Okay. Now this, is it some finite element? Is it a finite natural number? No. That means this implies me my S is infinite. It's so simple, right? So why I'm interested in this? Why I'm interested in this? Because the converse of this statement is not true. Just note it again. Converse of the statement is not true. If my S is an infinite set, that does not implies me there is a bijection with set of all natural numbers. For example, my set of real number is infinite. Okay, my set of real number is an infinite set, but there does not exist any bijection of R with set of all natural numbers. Okay, in the intro video I have just tried to give you some knowledge about infinite set. That time I have told you guys that my alif naught is less than C, where alif naught is nothing but cardinality of set of all natural numbers, and this is nothing but what? This is nothing but the cardinality of set of all real numbers. Okay, since there is a strict inequality between both of them, these two sets cannot have any bijection between them. Suppose if there exists a bijection between set of all natural numbers and real numbers, then I must have the cardinality must be same, which gives me a contradiction, correct? Hence I know that the converse of the statement will not be true. Also we note that if there is a bijection between two sets, then they have the same cardinality. Okay, simple. Okay, let us just go to the next page. If you feel that I am going a little bit fast or slow, just let me know in the comment box. Okay, let's see the next page. This is nothing but an examples. You guys can prove it definitely. So in this example 1, I am trying to give S a set of all natural numbers such that my n is a number greater than 10 raised to 9. Second, I am giving S is a set of all natural numbers such that 2 divides. Okay, so what is the task for you guys? You guys have to prove that my set S is nothing but equivalent to n. Means what you guys will prove? You guys will prove that between set S and set n there is a bijection, right? There exists a bijective map. It's really simple. For the first one, if I give you hint, what you guys will do? You will take my 10 raised to 9 to 1. 10 raised to 9 plus 1 you will get mapped to. So for the first one, let me just give you guys a hint. For the first one, you will map 10 raised to 9 to 1. 10 raised to 9 plus 1 you will get mapped to 2. 10 raised to 9 plus 2 will get mapped to 3, and so on. This map will be nothing but my f of, okay, you guys are going from S to set of all natural numbers. So this is nothing but get map my 10 raised to 9 plus x will get mapped to x plus 1. Okay, you guys will prove this is nothing but a 1-1 map, this is nothing but onto map, hence this will be true for the first one. Similarly, you can think about this is nothing but what, 2 divides n means what, this is nothing but set of all even numbers. Wait, this is something interesting, right? Inside a set, I am telling you there exists a set which has the same cardinality. This thing is not true inside a finite set, but infinite set has this beautiful property that inside a set you can have another subset, a proper subset which has the same cardinality. This is the beauty of an infinite set. This beautiful relation of the infinite set we will see in the next video when we will be discussing the topic called as a countable sets. Really interesting topic. In that we will talk about these things in a detail, and one of the most famous example we will discuss in the next video. Thank you so much guys for watching this video till the end. If you like it, just share it with your friend and subscribe to the channel. Okay, bye bye guys.